Yes, sorry for the delay. Welcome to NEET CET Mentors channel. Today's chapter is electric charges and fields, and I have uploaded the schedule you before yesterday, and the schedule will be followed continuously. Be with that schedule as NEET will be on 4th. I will be finishing it by 30th April. So do follow the schedule, okay? Without any delay, we will be starting solving the question. Yes. An electric line of a force in the xy plane is given by equation x square plus y square is equal to 1. A particle with a unit positive charge initially at a rest at a point x is equal to 1, y is equal to 0 in the xy plane. Then the options are given. The charge will not move at all, will move along the straight line, will move along the circular line of force. Information is insufficient to draw any conclusion. See how to tackle this question means they have given the equation that is x square plus y square is equal to 1. I think you will be getting that this equation will be of a circular motion equation, and the charge is initially at x is equal to 1 and y is equal to 0 in the xy plane. So by the equation we can conclude that charge will move along the circular line of a force because x square plus y square is equal to 1. From this equation we can conclude the charge will move along the circular line of force as the equation follows the x square plus y square. Yes, is it okay? You know the circular motion equation is x square plus y square is equal to 1. So the answer will be second option will move along the third option will move along the circular lines of force. Yes, moving. Yes, moving on to next question. See, cathode rays are traveling from east to west, enter into a region of electric field directed from north to south in the plane of a paper. Okay, the deflection of the cathode rays towards eastwards. Options are first one east, second south, third west, and fourth north. See, when cathode rays you consider means the cathode rays are always cathode rays means negative charged rays, right? Negative charged rays means always in the electric according to the electric force concept, the positive charge attracts a negative charge. Again, and the like charges, like if at all positive charges means they will repel each other. As the same, if at all unlike charges, positive and negative charge means they will attract each other. According to that, you can guess this answer. They are means how the electric field in this, see, the electric field directed from north to south in the plane of paper, then the deflection of the cathode ray. Electric field is formed from the positive charge, means for example, if these positive charge will flow, they are telling they are towards the from north to the south, right? Like this electric field is going, then how will be the deflection of the cathode rays there? See, if it is electric field going in the north to south, means these cathode rays will attract by this electric field, so which are negatively charged, so the negative charge attraction will be towards opposite to the electric field, exactly. So the direction of the cathode rays is towards the direction is towards north. Okay, direction is towards the north, which is opposite to the electric field direction. Let's recap it in 20 seconds. Moving on to the next question. See here, a simple pendulum of time period t has a metal bob which is negatively charged. If it is allowed to oscillate above a positively charged metal plate, its period will be, options are, remains equal to t, less than t, greater than t, infinite. You know, as the time period is given by t is equal to 2 pi root of L by G, where L denotes the length, G denotes the acceleration due to gravity. They are telling the pendulum is oscillating over the positive metallic surface. Then this metal bob is again they are telling it is negatively charged, which is oscillating over the positive charged metal plate. So what will affect to this equation? See, 2 pi which is constant, again length of the pendulum which is constant, the gravity is the only reason here which is altering the time period. So t, which is here, by the equation you can conclude that t is inversely proportional to the root of the gravity. Then means here, as the bob is negatively charged and this is positive charge, I have told just now only, the unlike charges will always attract each other. If it is attracting, means then this gravity is acting more on towards the downward, so which will cause if this force gravity is increasing now, the gravity increasing due to positive charge, if the gravity value increases, means the time period which is inversely proportional to the root of gravity, which must to decrease, right? See, 2 pi root of L by G, where G is inversely proportional to the time period, as the positive metal plate which is kept below and bob is negatively charged, so the time period which is inversely proportional to root G, as the force of acceleration due to gravity is increasing towards the downward, you can see it as a G plus the A, like that only, and which is increasing, mean time period will decrease due to the attraction. Okay, next, recall it. Yes, moving on to the next question. A charge q is uniformly distributed over a thin half of ring of a radius r. The electric field at the center of the ring is, see, they are telling, if half of the ring is there, example, take it as a half of a ring, they are asking about the which is of a radius r. They are asking electric field at the center of the ring is. At this point, what is the electric field they are asking? These type of questions is will be directly asked in the NEET exams, which will this actually takes the means we have to derive it from the concept of electric force, which will usually take 5 minutes also. So these type of questions you have to prepare with the formula only. Directly you have to remember the formula. If they are asking means which will be exactly helping you. So for this, how to just formula, you know how to find this. If at all the problem is based on this question, then you have to use the formula, that is electric field at a center is equal to charge q by 2 pi square epsilon naught radius square. This is the formula. If at all the data is given to solve the problem, means you have to use this formula, which is the option 1. I am directly solving this as it will require 5 minutes of derivation. So derivation is not important in the NEET. Just remember the formula. Okay, remember this, that is electric field at the center of the half of the ring is given by q by 2 pi square epsilon naught capital R square, that is R denotes the radius of the sphere, sorry, radius of the ring. Yes, moving on to the next question. See, the insulation property of a air breaks down at a E is equal to 3 into 10 power 6 volt per meter. The maximum charge that can be given to a metal sphere of a diameter 5 meter is approximately. They are telling, means what they have given here, the data is, yes, they are given electric field and they are given a diameter of the metal sphere. They are asking about the charge at that point is, maximum charge that given to the metal sphere is. See, the basic formula from the electric charges and fields, that is E is equal to 1 by 4 pi epsilon naught. E is equal to 1 by 4 pi epsilon naught q by r square, right? So do substitute this. They have given E is equal to 3 into 10 power of 6 volt per meter and 1 by 4 pi epsilon, which is a constant. I will be substitute value later. The q given a charge, we have to put a q as q and radius here, but the given diameter. Diameter is equal to 2r. R is equal to d by 2. So substitute d by 2, which has a square on it. So get the equation for the q, that is q is equal to d they have given, which is also 5 by 2 whole square. 5 by 2 whole square means 25 by 4. Then 3 into 10 power of 6, 3 into 10 power of 6 into 25 by 4 divided by 9 into 10 power of 9. You know, for 1 by 4 pi epsilon is equal to 9 into 10 power of 9. So we will be getting 2 into 10 power of minus 3 coulomb. So the option is second one. Resolve it in 20 seconds. I will be with the next question. Yes, the electric field E due to uniformly charged non-conducting sphere of a radius r as a function of the distance r from its center is represented graphically by. They are telling about the electric field on the non-conducting sphere, right? From the center is represented by. See, the axis here given, this is the origin where at this point, which is on the exactly on the surface of the sphere, and this is towards the surface which is going away from the sphere, and the area going away from the surface of the sphere. So for the non-conducting sphere, we can we have, you know, the graph that is E versus radius r, which is given by as on E is equal to, you know, 1 by 4 pi epsilon naught q by r square, which is away from the surface of the sphere. This equation which represents the electric field away from the sphere, surface of the sphere. So this graph will be like this, and again, you know, other equation that is E is equal to 1 by 4 pi epsilon naught q by r. So here again E is, sorry, this not this equation. This is on the outer surface of the sphere, where E is directly proportional to R within the surface of the sphere. So if E is directly proportional to the R, which is directly proportional graph without square means, which represents the straight line slope along the E and R. So the answer on the electric field on the non-conducting sphere will be option 3. Yes, moving on to the next question. A point charge Q is placed at a distance a by 2 directly above the center of the square of a side A. The electric flux through the one of its faces. You know, from the Gaussian law, that is, the charge which is at the center is enclosed by the square of side A. Which is having a side of length A and charge is kept at the center of the square. Electric flux through this they are asking. Make this as as a cube, not square, cube. Because the Gaussian surface is applicable within the closed surface. Okay, if it is in the cube, then they are asking through the one face only. See, the cube will be having a 6 faces and the charge is at the center. If they ask at the total electric flux through the cube, means the answer will be flux is equal to Q by epsilon naught. But they are asking through the question they are asking through the one faces. So phi, that is electric flux is equal to charge enclosed by the how much faces? 6 faces. So 6 epsilon. This is what the answer will be. Like that, they can ask through the opposite sides. Then it will be flux is equal to Q by 3 epsilon naught. Like that, they can ask different questions from this topic. So the option will be fourth. Moving on to the next question. A square surface of side L meter in the plane of the paper is placed in a uniform electric field E acting along the same plane at an angle theta with the horizontal side of the square as shown in the figure. The electric flux linked with the surface is. Okay. See, take a for example, this electric field lines are going towards the z-axis. They are on towards the z-axis, and this theta, which is along the, they are asking along the x-axis. So we can make that the angle between the z-axis and x-axis we all know, which is a 90 degree. And from the basics, again, the electric field is given by phi is equal to Ea cos theta. Electric flux which is given by Ea cos theta. You know what is a cos 90? Cos 90 is 0. Cos 90 is 0 means the flux through this entire sheet will be 0. Because it is a 90 degree, cos 90 is 0, so flux will be 0. So the option will be fourth one. Yes, this is the session of electric charges and fields. We will be teaching next session with the electric potential and capacitance. Be attend our live classes. Okay, it will be on 7 p.m. by today only. Yes, we will be ending the session.
ಚಂದ ನೋಡ್ಬೇಕು.